Here's the thing about assumptions. They feel so obvious that we stop questioning them entirely. And one of the biggest, most unchallenged assumptions sitting quietly in the back of most people's heads is this: Europeans have always been white. Like, obviously. That's just how it is. That's how it's always been. White people come from Europe. Everyone knows that. Except, and I need you to stay with me here, that is almost completely wrong. And the actual story of how and why Europeans became light-skinned is so much stranger, so much more recent, and so much more fascinating than anything your history textbook ever bothered to mention. So imagine this. You're standing in what will eventually become modern-day Britain. The year is somewhere around 8000 BCE. The last glaciers have retreated. The landscape is slowly becoming habitable again, and a small group of hunter-gatherers is making their way through the forest. These are the people who will, tens of thousands of years from now, become the ancestors of modern Europeans. They are skilled hunters, intelligent survivors, deeply human in every meaningful way. And they are dark-skinned, dark eyes, dark hair, brown to black complexion. This isn't a theory. This isn't a fringe academic argument. This is what the DNA evidence tells us, repeatedly and consistently. The oldest confirmed European hunter-gatherers, people like Cheddar Man, whose remains were found in Somerset, England, and date back roughly 10,000 years, had the genetic markers associated with dark skin pigmentation. The man whose skeleton inspired an entire British national identity, whose fossilized bones were displayed in museums as a symbol of ancient English ancestry, was almost certainly dark-skinned with blue eyes. The reaction when this finding was first announced publicly in 2018 was, to put it diplomatically, mixed. Some people found it genuinely fascinating. Others found it threatening to their sense of historical identity. A few people on the internet had what can only be described as a full biographical crisis about a 10,000-year-old skeleton. But here's what makes this story actually worth exploring. The question isn't just were ancient Europeans dark-skinned? The deeper, more interesting question is, why did that change? What happened? And why did it happen in Europe specifically? Because the answer involves a perfect storm of geography, diet, time pressure, and one of the most powerful forces in all of biology: survival pressure so extreme that it rewrote the skin of an entire population within a few thousand years. To understand any of this, you need to understand what skin pigmentation actually does. And I mean functionally, not aesthetically, not culturally, but biologically. The pigment that gives skin its color is called melanin. It's produced by cells called melanocytes, and it serves one primary biological purpose: protecting the DNA in your skin cells from damage caused by ultraviolet radiation from the sun. UV radiation is genuinely dangerous in high doses. It breaks down the molecular structure of DNA, causes mutations, and over time leads to skin cancer. Melanin absorbs UV radiation before it can penetrate deep into the skin and cause that damage. The more melanin you have, the more protected you are. This is why, across the history of human evolution, populations living close to the equator, in sub-Saharan Africa, South Asia, parts of Southeast Asia, consistently developed darker skin. More sunlight equals more UV radiation equals stronger evolutionary pressure to produce melanin and protect yourself. The math is brutally simple. The first anatomically modern humans emerged in Africa somewhere around 300,000 years ago, and the evidence suggests they were dark-skinned, which makes complete sense given that they were living directly under some of the most intense UV radiation on the planet. As those early humans migrated out of Africa and spread across the world, they carried their dark skin with them. The populations that moved into high UV environments kept that pigmentation. The populations that moved into lower UV environments, farther from the equator, where sunlight is weaker and comes at a lower angle, faced a very different set of pressures. And here's where it gets complicated, because losing melanin isn't just about not needing the protection anymore. There's a second critical reason why low melanin became advantageous in low sunlight environments, and it has nothing to do with UV damage. It has everything to do with vitamin D. Vitamin D is not optional. Your body needs it to absorb calcium, to maintain bone density, to support immune function, to regulate mood, and to perform about 1,000 other essential biological tasks. Without adequate vitamin D, you develop rickets, weakened bones, compromised immune response, and a cascade of other serious health problems. Vitamin D deficiency in pregnant women can cause severe complications for developing fetuses. Historically, it was a major cause of childhood death and disability. Now, here's the critical thing. Your body produces vitamin D through a process triggered by UVB radiation hitting your skin. The UVB rays trigger the conversion of a cholesterol compound in your skin into vitamin D3, which your body then processes and uses. This is your primary source of vitamin D in environments where food sources are limited. And here's the problem. Melanin, while excellent at blocking harmful UV radiation, is not selective. It blocks UVB right along with the more damaging UVA. So, in a high melanin individual living in a low sunlight environment, the melanin that was evolved to protect them is now blocking the very radiation they need to synthesize vitamin D. In equatorial Africa, where sunlight is intense year round and hits at a direct angle, even very dark skin lets through enough UVB for adequate vitamin D production. But take that same dark skin to northern Europe, where sunlight is weak, where winters are long, where the sun spends months hovering low on the horizon. And suddenly, vitamin D production becomes critically compromised. You're blocking the little bit of UVB you're getting, and you can't make enough vitamin D to survive well. Your bones weaken, your immune system falters, your reproductive success drops. Evolution, being the ruthless optimizer that it is, notices this. Or rather, individuals who happened to carry genetic mutations reducing melanin production had slightly higher vitamin D synthesis, slightly better health outcomes, slightly higher rates of surviving to reproduce. Over generations, those mutations spread through the population, not because light skin was better in some abstract sense, but because in that specific environment, in those specific conditions, it conferred a measurable survival advantage. But, and this is the part that most people completely skip over, this process was not instant. It was not even fast by human standards. The earliest anatomically modern humans arrived in Europe somewhere around 45,000 years ago. And yet the ancient European hunter-gatherers from as recently as 8,000 to 10,000 years ago were still predominantly dark-skinned, which means that for roughly 35,000 years, these populations lived in low sunlight northern Europe and didn't dramatically lighten their skin. Why? How did they survive vitamin D deficiency for 35,000 years without going lighter? The answer, almost certainly, is diet. Hunter-gatherers, which is what these early Europeans were, had access to dietary sources of vitamin D that compensated for lower skin synthesis. Fish is an extraordinarily rich source of vitamin D. So is animal liver, fatty meats, and animal fat more broadly. A hunter-gatherer diet, particularly in coastal or river-adjacent environments, could provide enough dietary vitamin D to compensate for reduced skin synthesis. As long as you were eating well, and hunter-gatherers, contrary to popular image, often ate remarkably diverse and nutritionally rich diets, you didn't need to lighten your skin to survive. So the dietary buffer kept the vitamin D problem manageable, and the selection pressure for lighter skin remained relatively low. Dark skin persisted. Then something changed everything. Around 10,000 to 8,000 years ago, farming arrived in Europe. Not invented there, it was developed independently in the Fertile Crescent region of the Middle East and then spread westward, carried by migrating farmers who brought their seeds, their animals, and their entire way of life into Europe. These early farmers were themselves a different genetic population from the existing European hunter-gatherers, and their arrival represented one of the most dramatic demographic transformations in European prehistory. In many regions, the incoming farmers largely replaced the existing hunter-gatherer populations, not through warfare necessarily, but through sheer population growth that came with the agricultural surplus. But here's the crucial biological consequence of that dietary revolution. Farming changed what people ate in a way that catastrophically reduced dietary vitamin D intake. A farming diet in ancient Europe was dominated by grains: wheat, barley, rye, millet. These crops provided calories efficiently, which is why farming populations grew so dramatically. But grains contain virtually no vitamin D. The rich, fatty, diverse animal product diet that hunter-gatherers relied on, the fish, the organ meats, the wild game, was dramatically reduced. Farming populations ate more grain, fewer wild animals, less fish, unless they lived near water. Their dietary vitamin D intake plummeted. Now, suddenly, The equation changed. You have a population eating a low vitamin D diet, living in low sunlight northern Europe, with dark skin that's blocking what little UVB they're getting. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. The vitamin D buffer is gone. The selection pressure for lighter skin becomes intense, dramatically more intense than it had been for the previous 35,000 years. Because now the only way to maintain adequate vitamin D is to produce more of it through skin synthesis. And the only way to do that efficiently in weak sunlight is to have less melanin. The genetic data tells this story clearly. The mutations associated with light skin pigmentation in Europeans spread rapidly through European populations during the Neolithic period, the farming era, and continued spreading through the Bronze Age. This was not a gradual, barely perceptible drift. This was a relatively rapid genetic sweep, the kind that happens when a trait offers such a significant survival and reproductive advantage that it outcompetes other variants at high speed. And it wasn't just one mutation. That's another thing worth pausing on. Light skin in Europeans is not the result of a single genetic change. It's the result of multiple mutations in several different genes related to melanin production. Genes with names like SLC24A5, SLC45A2, TYRP1, and others that all converged to reduce pigmentation. Some of these mutations appear to have originated in populations that later migrated into Europe. Others arose in Europe itself. The light skin we associate with Northern Europeans today is the result of a complex, multi-gene, multi-population process that unfolded over thousands of years. Here's another layer that complicates the picture further. Not all light skin traits evolved at the same time or for the same reasons. Eye color and hair color, for example, have somewhat different evolutionary histories from skin color. The blue eyes that Cheddar Man apparently had are intriguing precisely because they seem to predate the skin lightening, suggesting that different pigmentation traits were under different selection pressures and evolved on different timescales. Blue eyes appear to trace back to a single ancestral mutation that occurred somewhere around 6,000 to 10,000 years ago in a population around the Black Sea, or Baltic region. Before that mutation, all humans had brown eyes. That one change in a gene called OCA2 spread through European populations, presumably because it conferred some advantage. Though, what exactly that advantage was remains a subject of genuine scientific debate. Some researchers suggest it might be related to low light vision. Others suggest it spread through sexual selection. People found it attractive, chose mates with it, and the trait spread that way. The honest answer is that we're not entirely certain. Blonde hair has its own separate evolutionary story. The mutations associated with light hair pigmentation in Europeans appear to be largely independent of the mutations affecting skin color, even though they're all happening in the same general population over the same general time frame. It's as if European populations were being recolored from several different directions simultaneously, each pigmentation system responding to its own set of pressures. And then there's a third major migration wave that completes the picture. Around 5,000 years ago, long after the farmer migration from the Middle East, another massive population movement swept into Europe from the Eurasian steppe. These were the Yamnaya people, semi-nomadic herders whose genetic legacy is visible in a huge proportion of modern Europeans, particularly in northern and eastern Europe. The Yamnaya contributed additional genetic variants related to pigmentation, and their arrival further scrambled and reshuffled the European gene pool. Modern Europeans are essentially a genetic mixture of three major ancestral populations: the original dark-skinned hunter-gatherers, the Neolithic farmers from the Middle East, and the Yamnaya steppe herders. Each group brought different genetic variants, different physical traits, and different pigmentation-related genes. The diversity of appearances you see across Europe today, the variation in skin tone, hair color, eye color, and everything else, is the product of those three populations mixing in different proportions in different regions over thousands of years. Scandinavia ended up with a higher proportion of steppe ancestry, which contributes to the very light features common there. Southern Europe retained more Neolithic farmer ancestry, which tends toward darker hair and eyes even with lighter skin. The specific regional variation across Europe is a map of those ancient migrations and admixtures. What's philosophically interesting about all of this, and worth sitting with, is what it says about the concept of race as a biological category. The skin color that many people treat as a fundamental, ancient, essential characteristic of European identity turns out to be a relatively recent adaptation driven by specific environmental and dietary pressures achieved through multiple independent mutations and arrived at through the mixing of populations that came from very different places. The white European of popular imagination is the product of an evolutionary process that wasn't complete until a few thousand years ago, in a population that itself was assembled from migrations spanning tens of thousands of years. This doesn't mean that skin color isn't real, or that differences in appearance don't exist. They clearly do, but the idea that those differences represent deep, ancient, essential boundaries between human populations is contradicted by the actual genetic and archaeological record at almost every turn. The boundaries are fuzzy, the timelines are recent, the causes are environmental, and the populations themselves were always moving, always mixing, always changing. There's also something worth noting about how recent and geographically specific this whole process was. Light skin evolved in European populations as an adaptation to European conditions, but similar adaptations, though through somewhat different genetic routes, also occurred independently in East Asian populations, in response to similar low sunlight pressures. This is a beautiful example of convergent evolution. Different populations arriving at similar phenotypic solutions through different genetic pathways because they faced similar environmental challenges. The light skin of a Swede and the lighter skin of a northern Chinese person are not the product of shared ancestry. They're the product of similar pressures acting on different gene pools in different ways. Meanwhile, populations in South Asia, the Middle East, and North Africa sit in intermediate zones and show intermediate levels of pigmentation that reflect the UV intensity of their environments and the dietary resources available to them over their evolutionary history. The whole global map of human skin color, when you look at it through this lens, is not a map of racial categories or ancient ethnic divisions. It's a map of sunlight intensity, dietary history, and the timescales over which different populations lived in different places. It's a survival manual written in melanin. Coming back to Europe specifically, and to the Cheddar Man skeleton that probably made some people very uncomfortable in 2018, the finding isn't a statement about modern identity or political ideology. It's simply what happened. 10,000 years ago, the people living where Britain now stands had dark skin. 5,000 years ago, that had largely changed, driven by farming, vitamin D pressure, and successive waves of migration. 2,000 years ago, Roman soldiers described the indigenous British as having red or blonde hair and fair skin. The transformation was real, it was rapid on geological timescales, and it happened for reasons that are completely explicable through biology and environmental pressure. The people who look at that Cheddar Man reconstruction and feel their sense of identity disrupted are experiencing something understandable. We attach meaning to ancestral continuity, but the science keeps showing us, over and over, that continuity is more complicated than it feels. The people who were here before us looked different. The people before them looked different still. And the people before them were walking out of Africa with the dark skin and warm climate adaptations that kept their ancestors alive for hundreds of thousands of years before anyone thought to head north. There's something almost poetic about it, honestly. The very same pigment that protected our African ancestors from devastating UV radiation became, in the different light of northern latitudes, an obstacle to the vitamin D synthesis that northern life demanded. And so the population slowly, generation by generation, turned down the melanin dial. Not out of any intention, not as part of any plan, but because the individuals who happened to make a little less of it had slightly healthier kids who lived slightly longer and had slightly more descendants. That's all evolution ever is in the end. Not a story of progress or purpose, just a series of small advantages compounding over time until the population looks nothing like it did 10,000 years before. Which is exactly how a dark-skinned hunter-gatherer walking through the forests of Somerset in 8000 BCE became the genetic ancestor of people who, a few thousand years later, would be described as fair-skinned inhabitants of a rainy northern island. The skin changed. The story continued. And the people, the fully human, fully complex, fully alive people, kept moving forward regardless, the same way they always had.